In the previous video clip, we worked out the numerical vega. The numerical vega of the option. So option, oops, not that one. It was numerical vega of a butterfly, and we used the spreadsheet. And in this video clip, I want to have a look at not just the numerical vega, but the analytical vega. And we want to estimate the analytical vega of the butterfly. So we go back to the basic butterfly strategy and just copy the payoffs of the butterfly in question, and we could take this one here, perhaps might be more straightforward. So we just work out, just copy and paste fresh. Now, what is the butterfly? The butterfly in this instance is the combination of 4 option positions, 3 options but 4 option positions. So we worked out the Black-Scholes value of each call with these parameter inputs. And then to form the butterfly, it was the long call with the lower exercise. We longed C3 with the higher exercise, and then 2 short positions at the middle exercise. We could in fact put this, okay, we'll delete this cell just to make a little bit of space, or delete a row. And we'll do the same here, except we'll work out individual values of the vega and then the vega of the portfolio. So if you go into the developer tab, and you'll see we have here the vega formula. The vega for the call and the put is the same. So I just copy the function name and the reference to the parameters in the parentheses and put beneath, and say okay, paste, and then I'd say equal to the vega of the stock, the exercise, the maturity, the risk-free rate, and I highlight the dividend yield and the volatility. And you can see the cell referencing is incorporated in. If I just drag across, then I have the vega for this option position and the vega for the third option position. So if you think this is BS call, and this is the vega, and then the vega for the entire portfolio would be equal to, very simply, we long the first call, so we go long the vega, plus long the last vega, minus 2 multiplied by the middle exercise, option with the middle exercise. And so if you like, the vega of the butterfly is simply replicating the butterfly positions, and that's what we use to calculate the premium on the butterfly strategy. So we've basically took the option positions that were used to construct the butterfly and then used those option positions equally weighted to work out the value of vega. And because we went short 2 call options, we double the middle vega and subtract away from the other 2. Okay, so let's then just take what I'd like to do is to compare this Vega here with what we had observed previously. Okay, so we'll say take the value of 10, 20, 30 and bring it down to 200, and then we'll set this cell here equal to the Vega of the portfolio, and then to fill in the missing cells we just go to Data tab, What If Analysis, Data Table, and the parameter input is stock price. So we want to rerun this Vega estimation for the butterfly, but for a range of different stock prices. So we'll go back to the original reference for the stock price, and it fills in, and we can very quickly insert a graph, and you can see we get the same basic shape as before. So in the previous instance, this is the shape that we had. Now, do the values compare? Well, let's just delete out the chart for a moment, and let's look at the numerical Vegas for a second. So we'll put this to one side, and we'll just take these values here and copy and paste across. So we'll say paste special values just to make the comparison. So this is the, if you like, the analytical Vega, and we're comparing it to the previous numerical Vega. And okay, there is small difference, but not too significantly out of kilter with each other. And the analytical Vega here at 40 seems to be pretty close, quite close, and all the way through. And at 150, the analytical Vega and the numerical Vega very, very close, and likewise here. And if we're to map these, if we were to insert a graph, insert a graph, and just select, so select data, add, and we'll say numerical Vega, and took the X values, these are the underlying stock prices, and the numerical Vega is this range here. Okay, we can observe that, and then put in, add the analytical Vega for this butterfly. And same range of stock prices, and the analytical Vega is this one here. It's clear there's virtually no difference between the two. These are practically, for our purposes, purely in terms of simple visualization, the values tend to coincide, and that's clear also from the pattern of the numbers. Okay, so this is the analytical Vega compared to the numerical Vega, and we found that they converge. Okay, so analytical Vega compared to the numerical Vega.